Hello and welcome to my next video. With this topic, elasticity, we're turning away from just the micro foundations of the course, microeconomics. Now we're into the true heart of microeconomics. In other words, this topic is typically, occasionally, but typically it's not covered in macroeconomics. So the topics will diverge from here on out. Now, elasticity is the concept of how responsive is a change in one variable to a change in another variable that's related. So the sensitivity, if you will, of one variable related to another. So as an example, what happens if you study one more hour per week? How will that affect your grade in economics? Now, excuse me, by just saying one more hour and points on your grade, sometimes the way we measure things will be different, and so that's not always a valid way of thinking about it. A better question might be, if I increase my study time by 10%, then how will that change my grade? So we're going to look at percent changes. There's a problem, though, when we're looking at percent changes that result in a percentage value then. And let me explain. Suppose that you get a raise, and that raise goes from $100 a day to $120 a day. Well, obviously, doing the percent change calculation, that's a 20% increase. However, if we use those same numbers, $100, $120, but you got a demotion where your pay is cut from $120 a day to $100, then the percentage change, yes, it's negative, but notice the absolute value of the numbers are different. Here it's not 20%, but 16.6%. So whether we're going up or down, we'll change the percentage calculations because of the denominator on our percent calculations. So here's what we want to do. On elasticity, we really want those numbers to come out the same, whether we're going up or down on the numbers. So the way we do that is we just take an average of those denominator values, if you will. And so to do that, for example, if we're taking an average of the $100 a day at 120, that would be 110. So we use, if you want to think about it this way, and it is a good way to think about it, if you we want to use the midpoint for our percent change calculations. All right, so let's do an example. So let's suppose that you sell some type of streaming media player, and let's say it's 40 bucks. But that company is deciding whether or not they could sell more at a price of $30 and whether it would overcome loss of the $10 per unit in terms of profits. So what should that business do? Well, it's a good way to think about it in terms of elasticity. So it depends on your cost structure. Let's assume that it's not changing. So is lowering the price going to increase the quantity demanded by more in terms of a percentage than the lowering the price? Okay, so what we're looking at here is, if I'm selling this streaming media player for $40, will I actually increase my profits? And let's back off and just think about total sales to begin with, because we're going to assume the cost structure is the same. So we're just looking at total revenue changes. So if I lower my price for the media player from 40 to $30, that's going to cut down on my total revenue if I sold the same amount. But from the law of demand, I'm hoping to sell a lot more because of the drop in price. So what's going to happen to my total sales when I do that? Well, that's called total revenue in economics, and total revenue is the price of the good times the quantity that's sold. So if I raise my price how responsive are customers to price increases. If I lower my price, how responsive are customers to lower prices. So this is just a hypothetical demand curve for the streaming media player, particular type that we're talking about here. So we see, for example, at point B, that if the price is $40, 20 will be sold, 20 per day. Now that this might be in one store. You could add thousands or millions to it if you're talking about for the country as a whole. If we lower the price to $30, the quantity demanded goes up by 40. Again, we could add zeros to make it relevant, but I like small numbers, as you may know by now, so we'll just go with the number 40. So to put this in a sentence form, so if you lower your price from $40 to $30, then sales will change from $20 a day, 20 units a day to 40 units a day. So total revenue will actually increase because the 40 times the 20 that's sold, that's 800. So $800 a day at $40. At 30, now we're selling 40 units. So 30 times 40, that's 1,200. So we have an increase in our total revenue by $400. So it would benefit us to do this. Now, why does total revenue increase when the price decreases? Because the percent change in quantity demanded is increasing by more than the percent change in price, which is decreasing. In other words, the absolute value of the percentage change in quantity demand is greater than the percentage change in, technically it's percent change in price. So it's very important for businesses to know the price sensitivity of customers to particular products and services. And again, that's where elasticity plays a big role. So the coefficient of price elasticity demand, fancy term, sometimes you'll just hear it called elasticity of demand, but here's the whole technical name. But from now on, I'm going to just call it the PED, the price elasticity demand. The formula for that is the percent change in quantity demanded divided by the percent change in the price. But as I mentioned earlier, since we want the values to not be different if we're going up a demand curve or down a demand curve, we're going to actually take the average of the quantity demanded. So that's the Q2 plus Q1 divided by 2. We're going to take the average of the prices. So to calculate the percent change, we're going to take the difference in the quantities divided by the average in the quantities, and that all divided by the difference in the prices divided by the average in the difference in the prices divided by the average in the prices. So if you think about the mathematics involved, you're dividing fractions. So mathematically, some of that will cancel out, and the formula can be reduced to the difference in the quantities divided by the sum of the two quantities, divided by the difference in the prices, divided by the sum of the prices. Again, that's just a mathematical simplification of fractions divided by fractions. Now, some terminology. This is going to be important that you know the terminology. If the absolute value, we know with the law of demand, the value is going to be negative, but we want to look at the magnitude of the numbers, not counting the negative sign. So if the absolute value of the price elasticity demand is greater than 1, we call that item elastic. If it's less than 1, it's inelastic. If it's exactly equal to 1, it's called unit or unitary elastic. Now, two other possibilities. If we get a huge number, we can even say it's close to infinity, we call that perfectly elastic. And if there is no sensitivity to price changes at all, the elasticity calculation would give us a numerical value of 0. That's called perfectly inelastic. There is no sensitivity at all. Now, the next formula I'm going to show you, I have never seen in any of the principles of economics books, but it is so much easier to use in terms of the calculation that this is the route I'm going to go. Now, word of warning, This is strictly in terms of actually being able to use it. You can use it on nonlinear demand curves, but you've got to be careful. So let's strictly have this relate to linear demand curves. And this is just a simplification of the formula. So this is the point price elasticity demand. This is actually more accurate because we're talking about a point. Technically, I guess you'd say 2 points that are so close together that they can be approximated as a single point. So here is the formula. Again, it's not in the books, but this will make your life easier if you can understand this formula and utilize it if it's a linear demand curve. So 1 over the absolute value of the slope times P over Q. Much, much easier to use. Now, along a given linear demand curve, these elasticity values will not be the same. So even though the slope is the same, and yes, that is part of the point price elasticity calculation, this part, but the P over the Q will vary. And so elasticity is not the same along linear demand curves. As a matter of fact, there's a pattern. So as we move from one point on a demand curve down to another, the elasticity calculations will be different, and the relative slope will impact in terms of, so we would say here, this D1 curve is a little more elastic than the D2, and we'll see that in upcoming calculations. Now the extremes, the D1 curve, demand curve, that's perfectly elastic. The D2 curve is perfectly inelastic. So those will be important for later topics. So why does elasticity vary among different goods? Well, certainly if you have a whole lot of items that have very similar characteristics, this may vary with you, but for me, Pepsi and Coke and Dr. Pepper, in other words, sodas, they're about all the same to me. And so I am very price sensitive. If the price of Coca-Cola goes up, but the price of Dr. Pepper doesn't, I'm going to be very responsive and change from buying Coca-Cola into Dr. Pepper, as an example. So the number and closeness of the substitutes, the more there are of close substitutes, the more elastic that item will be price elastic. And also, let's say salt goes up by 50%. Well, it's such a small price anyway for a shaker of salt or a container of salt. That's not going to be a big hit on your overall budget. But let's say the price of a car goes up by 50%. Yeah, that's big time. And so the larger the price is relative to your overall budget, the more elastic the demand will be for that product. In other words, salt would be very inelastic because price changes are not that big a deal. Automobile prices are more elastic because it's a big budget change when the price goes up by a certain percent. And certainly time. For example, gasoline. Over the short run, if gasoline goes up by, let's say, 50%, there's not a whole lot we can do about it in the short run because we've got to have gas to get to work. But the longer we have, we're going to search out alternatives. We might start carpooling more. We might consider buying electric vehicles or other kind of options. So the longer the time, the more elastic things tend to be in terms of their sensitivity to price changes. So let's do a numerical example. So let's suppose we've got shoes and they're at first $60, and at $60 there's 160 sold. Again, we could add zeros, but let's keep it simple. And if the price goes up to $70, 120 are sold. Again, the law of demand. So doing the calculations, and you can stop this if you want to look at all the calculations. I'm using and technically, that's the ARC formula for elasticity, and that's the one that's in the e-text, I do believe. You'll see that value comes out in terms of its absolute value to be approximately about 1.86. Now that's greater than 1, so we would say that demand is elastic over this range for this particular type of shoe. Let's utilize that same calculation, or excuse me, same $60 and so on and so forth, and $70, but apply the point price elasticity formula. Well, instead of the 60 and the 70, we'd use what's right in between 65 and instead of using 120 and 160 in the calculations, we'd use what's right in between 140. And then we also do have to have the calculation of the slope. So remember, on slope, we pick any two particular points. And so this might be a good point. So from 80 and 80, this doesn't start at 0 because I didn't want to stretch it way out. From 80 to 80, well, let's use the 70 because that's what I used in my next slide. From $70 and 120, or to say it mathematically correctly in terms of X and Y, 120 and 70. Okay, down to 60 and 160. That's the prices we're talking about. The slope there is a negative 1/4. And so here's your calculations. All right. So now we've got the different numbers that we can use to do the calculations. So the point price elasticity would be 1 over the absolute value of the slope, which would be 1 over negative 1/4. The absolute value would be 4. 1 over 1/4 is 4. And then we're going to use the midpoints, the average of the price, average of the quantity, so that's 65 and 140. And lo and behold, guess what? We come out exactly the same value. So this is a much simpler way of doing the calculations if it's a linear demand curve. Now, this is also easier if you're going from a formula for the demand curve, such as price equals negative 1/4 Q plus 100. That's actually the formula for the demand curve that we looked at. And now you just plug in a particular quantity. They'll give you the price of that quantity using this formula. And you can then easily, because you already have the slope, and you can do 1 over the slope absolute value, which again was 4 in this case. So you can take any two prices and quantities, quickly plug those in, because if you're working on the same demand curve, that slope, 1 over the absolute value slope's not going to change. So you got the 4, and you can plug in different price quantity combinations and very quickly come up with the value for the point price elasticity. In this example, when we're talking about $50 and 200, and that's what's our point's going to be that we plug in here, that comes out to a value of 1. So demand would be unit elastic here. On that demand curve, if we're at $35, and that corresponds to 260, you can go back on the video and look at that graph of that demand curve. Then we get approximate value of 0.54, since that's less. Top part is first elastic, left to right, starting toward the top, left, then unit elastic, then inelastic. And if you have a demand curve that is you're calculating right at the midpoint, that's going to give you a unit elastic calculation. Now, I spent a lot of time on price elasticity demand. The good news is that the price elasticity supply, it's exactly the same calculations, except now we're talking about quantity supplied as opposed to quantity demanded. So we can use the same concepts of elastic, inelastic, except we don't have to worry about the absolute value here because supply curves generally have positive slopes. I mean, we could tack on the absolute value. It's not going to change the sign since it's already positive. There are lots of elasticity concepts. So another good one is the income elasticity of demand. In other words, when we have a certain percent change in income, how does that impact our demand for the product? And notice here we're saying demand as opposed to quantity demanded. Remember that nitpicky terminology. If when you do this calculation, that number comes, here we don't take the absolute value, by the way, the sign matters. So calculation, the number comes out to be positive, it means it's a normal good. Let's think about what that's saying. That's saying when your income goes up, purchasing, the demand goes up. That's a rightward shift. Well, that's normally what happens with a normal good. But if your income goes up and you actually purchase less of it, that would be a decrease in demand. That would be a negative relationship. So that would be an inferior good. Another very useful elasticity calculation is the cross price elasticity. So we're talking about what happens to the demand for good X, what happens to the demand for Coca-Cola when the price of Pepsi-Cola changes. So this is the difference in the two different demands and the difference in the price. So what happens here? Well, again, sign matters. We don't take absolute value. So a positive cross elasticity of demand means that the goods are substitutes. So if the price of Coca-Cola, when it goes up, the demand for Pepsi also goes up. And that means people switching out of Coca-Cola into Pepsi. Those are substitutes, at least from my perspective. If, on the other hand, that cross elasticity demand calculation gives us a negative number, then that means those are complementary goods. If the price of nacho cheese goes up, then the demand for nacho chips probably would go down. In other words, opposite direction, because the fact that the cheese is more expensive, so we buy less cheese, so we eat less nachos, the nacho chips. So this is a good overall viewing of what happens with elasticity and why it's important. And you're going to especially need to hang on to these concepts, especially how total revenue reacts to the elasticity of demand, because later on that will enter into decision making on the part of the entrepreneur.